Right, now in this video, we're going to use this bipartite graph here to determine a squared. So some of you may know matrix multiplication. I don't want you to use that. You can find matrix multiplication over the internet. I'd like you to be able to do it without matrix multiplication. You could certainly use matrix multiplication websites, many of them out there, to check your work. Perfectly fine. But I'd like you to know the concept. All right, so we've got a squared here. We want to find a squared. Now, I'm going to start with a grid. That makes it easier, I think. V1, V2, V3, V4, V5, V1, V2, V5. All right, so first thing we can do is just go down the diagonal with, remember that from the previous video, we know that the degree of, that the diagonal entries are the degrees. Because the number of two edge walks from V1 to V1 is exactly that walk there. So degree of V1 we see is 1. The degree of V2 is 2. The degree of V3 is 1. The degree of V4 is 1. And the degree of V5 is 3. Right, so we have those. So now V1, V2, or this entry here, the 1, 2 entry, a squared 1, 2. This is the number of walks from V1 to V2. How many different walks are there from V1 to V2? Let's see. 1 there, and that looks like it. So there's just one of them. Oops. 1. So by symmetry, we can fill that in there. All right, now V3. So V1, V3, the number of two edge walks from V1 to V3. Let's see, you got this one there. So just one of them there. The number of two edge walks from V1 to V4, there are none, right? So there is a walk from V1 to V4, but it has 1, 2, 3 edges. So two edge walks, there's none of them. V1, V5, two edge walks. There's a 3 edge walk, right? 1, 2, 3, but there's no 2 edge walks. So a 0 there. Let's see, by symmetry, we can go like so. Let's see, right? Does that make sense? 1 to 1, yeah, okay. 1 to 2, one of those. 1 to 3, one of those. 1 to 4, none of those. From 1 to 5, none there. Okay. So V2 to V3, how many two edge walks from V2 to V3? Let's see, you have 1 there, and I think that's just 1. There's just one two edge walk from V2. Oh, was it V2 to V3? No, did I write? Okay, so V2 to V3, right? It was this one right here. There's just one. V2 to V3. That's that one there. V2 to V3. Okay. There it is. Okay, so 2, 3, 3, 2 is a 1 as well. Okay, so V2 to V4, there are none. And so V2 to V4, there are none. And V2 to V5, there are none. There's a walk, a one-edge walk, but not a two-edge walk. Right, does that make sense? So if you're over here, right, to get over to V4, you can't do it with two edges. You could do it with three, like that. Over, back, over again. But you couldn't do it with two edges. All right, V3, V4, again, there are none. V3, V5, there are none. All right, so now V4, looking at V4 to V2, a two-edge walk. There are none. V4 to V3, there are no two-edge walks. V4 to V5, there is a two-edge walk, like that. Okay, V5 to V2, none. V5 to V3, there are none. V5 to V4, by symmetry, so 4, 5, 5, 4, right? Okay, now eliminate this stuff here. And now we have the matrix A squared.